Can you hear me? Oh, there it goes. Well, welcome. Hopefully you're here to hear about some Kotlin, because that's what I'm going to be talking about. And so when I submitted this, I submitted it under the title Undercover Kotlin, because sometimes it's hard to introduce new languages to workplaces, and I thought it's a little, I don't know, deceptive. And so I've started calling it Getting Dressed Up for the Party, because now Kotlin is more widely accepted. But anyways, we're going to be talking about how to use Kotlin and let people like your Java coworkers use it. So before we get started, how many of you have used Kotlin before? A handful. You're just thinking about it? Okay. I'm not going to cover a whole lot of the basics of Kotlin necessarily, but if you have questions, I like my talks to be very interactive, and sometimes that works for audiences and sometimes it doesn't. But if you have a question, don't be shy. I don't mind. Raise your hand and ask. So anyways, just a quick introduction about who I am and why I might matter. So I work at Red Hat at the moment, and I work on a project called Quarkus. If you're familiar with Quarkus, it's a micro-profile-based framework. So I'm an engineer on that team. So I'm a Java champion. So while I'm here talking about Kotlin, I still love Java quite a bit. So the idea that these two can work together is important for me, because I live in both worlds now. So the fact that we can work together is important. So I've been doing Java since 1996, pretty much since there was a Java. So when I say I love Java, like I have 23 years now of loving Java. So yeah, anyways. But I've been using Kotlin for about 6 or 7 years now. And it's exciting to me because when I first started, there weren't too many people that were using Kotlin, and now everyone uses Kotlin, which makes me happy. And I also do a lot of open source stuff, which may or may not matter. So just briefly, that's who I am. In case it matters, it gives a little bit of context to why you might care about what I think. I'm going to do, this is the end of my slides, essentially. I'm going to work in the IDE, and we're going to work through some code. And like I said, I like them to be interactive. And one of the nice things about working with code is if I do something and you have a question, I can actually stop and we can dive into it, as opposed with slides. If it's not on the next slide, you're kind of out of luck, right? So I do like to take questions, so please don't be shy. And let's get out of that, and we'll pull up the IDE. Wow. Is that readable? It's all like dots this close. I didn't have a chance to fix the font. So we're going to do that now, because that is bananas. Where's the font? Appearance and editor. I don't think this is the right one. Well, that's sort of readable, yeah? But I don't think it fixes the other problem. Editor general. Wow, that's not helpful. Appearance. I apologize. Usually I have a chance to fix it before I get up here, but everything was a little... Now that... Is that readable now? Perfect. Okay. So, all right. I'm going to block this side because that's where I'm standing, but this is just my script. So, just to show you what we've got. So this is the list of things I want to get through, and we're going to try and get through all of this. If all goes well, we'll get through all of it. But if you have questions, I'm happy to answer anything, and we'll get through what we can. So, okay, so the topic of this talk is how do we use Kotlin in a way that is usable from your Java libraries? Has anyone ever used a Scala library in Java? No? Okay, one of you. So one of the problems that I've had with Scala is that no matter how great the library is in Scala, if you try to use it from your Java applications, you can tell that you're using a Scala library, and it just feels weird. And one of the things I like about Kotlin is that you can actually use them from a Java library, and it doesn't really feel like Kotlin except for a few cases. So what we're going to look at today is what are some of those cases where the Kotlin nature of your library starts to feel like Kotlin in a Java library, and how we can fix it. And then we'll look at a few cases where there's just no way to fix it. It's going to feel like a Kotlin library in Java. But as long as you know that they're there, it's not terrible to work around. So one of the first things, the biggest tools that I use to make sure that the Kotlin library still feels natural to use in Java is to use Java unit tests. Because if you're just writing everything in Kotlin, everything feels fine, right? And you don't really feel how weird it is until you start trying to use it from Java. So one way to fix that is we just use JUnit, like we always have, but you write your test in Java instead of Kotlin. So you get like a first-hand feel of what your API feels like to a Java user. You can do both if you want. It's better to write in Kotlin code because it's nicer. But if you're trying to make sure that it feels natural, it's best to write at least some of your tests in Kotlin. So we're going to use this particular unit test over and over to kind of explore some of the Kotlin-y aspects of an API. So one of the nicer things that Kotlin offers is an object. Everyone's familiar with a Kotlin object? It's basically a named singleton, right? So you can't create a new instance of it, you just get one. And in Kotlin, you use it by the name type and everything works, and the compiler takes care of it for you. So if we look at this example, so we have an object and it's called a network. And if we want to use it in Kotlin, like I said, we can't say new network, right? So we get these red squiggles because the constructor is private, so we can't create a new instance. So that's fine. We'll just use it like a static class. And if we want to call, for example, this method shutdown, we want to shut down our network, this is what it looks like when you try to use this from Java. So we do a dot, and then of course IntelliJ gives us the autocomplete, and you can see here you get this weird instance thing. It's a little awkward, but if you've ever written a singleton in Java, like often you have like a static instance field, it's fine. So we use instance, and now we can call shutdown, right? So this is not terribly weird as Java developers, because if you've ever written a singleton, it kind of feels like this sometimes, but we can do better. So one way that we can do this, there's an annotation called @Jvm Static. Now what this instructs the Kotlin compiler to do is it generates the bytecode in such a way that it exposes this method as a static method on the network type. And then if you come back to your Kotlin, you can see now it's all in kind of yellow because IntelliJ is telling us that we can fix this, and it says access network.shutdown via the network reference. So now we can do this. Now, this looks like what it would look like in Kotlin, right? You have your type, have your function, and it's just there. It looks like a static method on this type, even though in Kotlin it's a little bit more complicated. So this is one way to kind of smooth over some of that particular rough edge. And it's also true if you have a class. Here we have another class over here. We'll just do this. So let's create a class. In this case, it's called Showcase. Everyone's familiar with the companion object in Kotlin? So in the same way that network is an object, every class in Kotlin gets a companion object. And this is, if you're not terribly familiar with Kotlin, where in Java you'd write a static function on your class. In Kotlin, you just put it on the companion object. So we can create a function that does whatever. And if we were trying to use it from Java, you'd have showcase dot, and then there's that companion. Okay, that's kind of weird, and now we can call foo. This works, it makes sense, but it's clearly there's something odd going on, right? But you can use the exact same approach if you apply the Jvm Static annotation to foo as well. You can come in here, and now it just looks like, again, a static member of your type. So Jvm Static is one way to expose features idiomatically to your Java coworkers so that it feels a little bit more natural. And we'll come back to that eventually. So another nicer feature of the Kotlin language is that, unlike in Java, you can have top-level functions and you can have top-level properties, right? In Java, everything's required to be in a class. In Kotlin, it doesn't care, right? So if we take a look down here, you see we have a property called test, and we have a function, and they're not wrapped in a class. And in Java, this would be illegal, right? Because it has to be wrapped in a class. So has anyone ever written? Yes. Oh, so the question, for those of you who couldn't hear it, is when you do this, the Jvm Static on this, can we still call foo through the companion reference? And the answer to that is yes, you still can. So at the bytecode level, there's actually, we can take a look at it. If you want to see, one of the nice things about IntelliJ is you can do, there's this option. Show Kotlin bytecode. So when how many of you can read bytecode? Yeah, exactly. Some of it I can read and some of it is a little bit just whatever. So this can be mostly helpful for most of us. I'm not great at bytecode, but we can see, if we take off the Jvm static, so here's our public final foo on, you can see here, this is the showcase, and it's an inner type called companion, and it's just a final method on foo. And if we add back the Jvm static, it starts to look a little bit different. You can see it lists the annotation, and then up in here, that's the type. So, okay, and so now it created, here you can see, here's a final static foo, and it happens to be defined, if you scroll up, on the class showcase. So it ends up creating two functions, and I'm going to guess one defers to the other. Yeah, so for those of you who don't read bytecode, and again, I'm not an expert, let me scroll up. What you're seeing here is it's getting a static reference to the companion object, and then it's invoking the method foo on the companion object. So it'll generate a static foo on the enclosing type, and then it just delegates to the companion object. So you get both. If you still want to refer it that way, you can. It feels a little weird to me, but you might have perfectly valid reasons for doing that. So, any other questions on that before we go on? Okay. So, top level types. If you've ever, let's close that because that is very noisy. So when you declare a type like this, a top level type, what happens in the bytecode is that Kotlin compiler actually generates a class for you. And in this case, it's based on the file name. And this file name, if we look at the tree, which is probably too small, it doesn't matter. In this case, it's a file called showcase.kt. And the Kotlin compiler will actually create a class, showcase.kt.class, which is helpful if you come in here. So now we can do stuff like this. We can call this top-level function, right? So showcase kt.toplevelFun. This is weird. Showcase kt, it's kind of an oddly named class. We don't like it. So one way to fix that is we can actually add an annotation. And there's one called Jvm Name. So the @Jvm Name annotation up here allows you to coerce a name to something that you'd like. We don't like showcase.kt, so we're just going to call it showcase, right? Well, that might be a problem, but let's call it, we'll call it this instead. Okay, so we're going to give it a name. Now, the acute observer might notice this red squiggle. Is that visible back there? The problem is, it looks like we're trying to apply an annotation to the package directive, which is weird, right? That makes no sense. So if you haven't seen this in Kotlin, there is, you can specify a target for an annotation. And in this case, we're going to say, apply this annotation to the file instead, which is strange, but We'll get to more of this later. So what that means now is that when it generates the class from this particular source file, it's not going to be called showcase.kt, it's going to be called this instead. Now you notice in our test we come back, showcase.kt is now gone. That type no longer exists. What does exist is this instead. And so now you can give it like a reasonable name that makes sense inside your application. But let's add another example. Come on, mouse. Let's say we have another file, and this file is called something else kt, and we have a function called another one, so we can come in here and say something else kt dot another one. So now we have another function that we're calling, and again, it's called something else kt, right? Which is not great. So we can just come in and fix this, and we can say add file colon Jvm name, and we're going to call this one this instead as well. Now, in theory, this is an error. Okay, so you see what happened here. Now we have this instead, another one. Oh, this is actually solid. But we've lost top-level fun, right? What happened to that one? Well, the problem is we're declaring two top-level, or two names called this instead, and kind of one overwrites the other. So we can fix that with this annotation. We can say add file. There's an annotation called Jvm multi-file class, and we can apply it to both types. Now what this annotation says is as the Kotlin compiler is collecting all these items, when it sees this annotation, it knows that there's another file somewhere that's using this same name. So it'll collect all those items, and it'll put it into one type, and now as you can see, we have both of our members. I personally don't use the multi-file class thing a lot because it feels a little weird to me to have things spread out a lot, but then I don't often use top-level functions. I've been doing Java long enough that having top-level members like this feels weird to me, but it's convenient at times, so sometimes I use it, but I still, part of me rebels at that because it's not a natural thing. So if you're going to use Jvm multi-file class, you have to use @jvm name, otherwise it doesn't know what name to use. It might actually, if we take it off, I think what will happen is it might just default to the same file name. Yeah. So if we did showcase. Oh, fascinating. Yeah, right. And then something. So if you don't give it a name, it'll just use the standard name that it has used. But if you specify, then if you specify a specific name, it'll work. So if you don't use them in conjunction, you don't really get much of a value out of using the multi-file class definition. So anyways, so this is how, and then the same way too as well, if you wanted to do the top level property. So in this case, we have a property called test, and if you're familiar with how Kotlin compiles, while it looks like a property in your Kotlin source code, what actually happens in the bytecode is there's actually a get and a set and a private field somewhere on the class. So on the bytecode level, you're actually invoking get test or set test. Just in the Kotlin source, you can kind of shortcut it and use the property name. But in the Java side of the world, yes? Microphone. Is it on?
One.
Oh, I hear you.
So can you declare these annotations on the package info level, something like that?
Kotlin doesn't have a package info. I know in Java there's that package-info.java.
Yeah.
I don't think Kotlin has that notion.
So it can aggregate all the functions, top-level functions, in the package.
I don't think you can do that on like a package level. You just you'd have to go into each file and do that.
Oh, I think.
We can certainly look into that, but I've not seen anything like the package info in Kotlin. So at any rate, from the Java side of the world, you don't see the test property. You see get test, set test, and you would call that accordingly, just like you would with your functions. And it also gets the benefit of the Jvm name and the multi-file class thing. So If you use top-level functions, this is handy. I don't a whole lot because I still find them weird. But, okay. Enough with the top-level stuff. Now, one of my favorite features in Kotlin is named parameters and default parameters. Surely everyone's familiar with those features in Kotlin, right? Some hands and a couple of shaking heads. Okay, so in Kotlin, so we're done with that function, and we'll come back to that one. So in Kotlin, you can specify what parameters, we'll come back to it. So when you're declaring a function, you can declare default parameters. So in this case, the name has a default value of name, and the age has a default value of 0. We'll come back to that question mark. So then, in your function, if you're going to call it, you can always assume that these have valid values, because they have default values. And where that comes into play is if we write another function we can call named, and we don't have to give it any parameters. The Kotlin compiler will fill in the defaults for you. It does this through a number of like synthetic methods and stuff in the bytecode, but from the source code, as far as you're concerned, you're just calling a method, a function, with no parameters. And then if we wanted to, we could say age is equal to 42. So if we only care about one parameter, we just give it a name. We just give it a name and a value, and then we can ignore all the other parameters and just use the default values. And this is awesome from Kotlin, because the compiler helps us. Java-C, on the other hand, doesn't know about named or default parameters. So if we were to call the same thing from our unit test here, and it was network. All right. Network.named. So as you can see here, we get the red squiggles because we're not passing any values, right? It doesn't know about the defaults. So what it looks like at the bytecode level, as you can see here, you can sort of read it, the parameters, it's expecting a name and an int for an age, and you have to pass those on the Java side. And maybe that's okay, and maybe it's not. If you have a lot of parameters, it starts to get pretty terrible pretty quickly. And you kind of lose the value of some of the name parameter stuff. So Kotlin provides an annotation called Jvm Overloads. Now what this does, this instructs the compiler to generate overloaded functions. And what it does is it will create one function that has all the parameters, and then it'll create another function without the age, right? And then it'll create another function without the name. So this will end up, because there's 2 parameters, you'll end up with 3 functions, methods from the Java side. And that looks like this. So if we come back here, now you can see, well, I'd up the font, but it makes everything else look weird. Here's one that takes every parameter. Here's one that takes just the first one, and now one that takes nothing. So now we can call it with, at least, depending on which ones you want to skip, you can start dropping off the later ones and call only like a certain subset. And this lets you at least pare down how much you have to pass in to a Java function. It's not as ideal as a named parameter, but until Java supports, named parameters, this is as good as we're going to get. So if you do a lot of these default parameters, you can make it nicer for your Java colleagues to call it by just adding Jvm Overloads. Okay, so we talked briefly about annotations and annotation targets. Now, I put this next one on a slide because it's just easier. Skip all that, blah, blah, blah. So these are, and I'm sorry, some of that you can't read. Anyways, so these are all the targets you can do on annotation. So we saw file. You can also do the property target, and it applies, annotations with this target are not visible to Java. So there's some weird interacts with the Java side that you want to be aware of. But you can apply it to a field, so we'll come back to it. So there are certain annotation-driven libraries that look for annotations on the field and not at the method level. Like Jackson, I don't think Jackson cares. It'll look on the get of a field, or for the getter for a field, or it looks on the field itself. But some of them aren't as robust, and they're specifically looking like, I need it on the field. In fact, I work on a library called Morphia, and it specifically looks for those annotations on the field. You can annotate the method all you like. doesn't matter, it'll never see it because it wants it on the field. So in that case, you can say @field, colon, and then whatever your annotation is, and the annotation will be applied to the field declaration of the bytecode rather than the getter. You can also do, if you need it specific on the setter, you can target that, or on the set. You can also target the receiver. I don't have an example of this one. I actually kind of just learned of this weekend, to be honest. If you have a Lambda with receiver, or an extension function with the receiver type, is everyone familiar with extension functions? Mostly? We can circle back to that because they're cool. But if you have an extension function, like you add a function to string, the string is the receiver type, and you can add an annotation to that part specifically if you like. You can add annotations to parameters to a function if you'd like. And down here, this is set param. This is the property setter parameter. I think this is mostly for constructor-based field declarations or property declarations. You can also have, you can also annotate a delegate. So if you're familiar with Kotlin delegates for like lazy initialization or whatever, you can apply an annotation to that delegate instead of the property itself. These are a little bit more kind of esoteric, kind of exotic uses of that particular whatever, but they're there if you'd like. So if we come back to that guy. So let's take a look once more at the bytecode, just because we can. So we have this class, we don't need all of that. If you have a property, var name, and we'll give it this. So if we're looking here, you can see we declare a property in our Kotlin source code, but if you look at the bytecode, you see like normal, we have a private string name. That's what you'd expect. So we can annotate, if we annotate, do I have Jackson on this? I don't. @nullable. We'll give it that annotation. So we have nullable, not null. We have get name. You can see the annotation kind of everywhere. But if we do @get, oh, it's going to make a fool out of me. Anyways, apparently it likes nullable. You can target specifically the property if you want, and it changes. See, there we go. You can see the bytecode change over here as I add and remove some of the stuff. Oh, I know why it's doing that, but that's a separate conversation. So if you want, you can target it, is what I'm trying to say, for those properties. And that can be useful in some cases if you need, especially with like object mappers can get kind of wonky. Okay, so those are some of the basic ways you can kind of smooth it over if you have to. Those are going to be the most common if you have objects or named parameters. Those are going to be your most obvious interactions with the Kotlin Java translation, where it's going to be weird. Now, there's a few cases where we can't quite smooth it over as much as I would like. But let's take a look at Nullable. Everyone, okay, most of us know Kotlin, or familiar with it. We're familiar with the Nullable type system, the nods. How many of you know how that works at the bytecode level? No hands. Awesome. I love sharing this because it's kind of a clever solution. Now, in Java, of course, if you had like a lowercase int and you assigned a null, if we came in here and we said int x is equal to null, that's a compiler error, right? Because a primitive can't be null, right? It all makes sense. If we wanted that, we would have to say integer, right? Now it makes sense, because integer is an object type, a reference type, and that can be null. So then the question is, when you're on the Kotlin side of the world, if you have, let's go back to this function. So age takes an int, right? We can't say int is equal to null, because int is not a nullable type, right? So we can do this, and now suddenly that's valid because null int question mark is nullable. So what does this look like from the Java side of the world? If we call, let's get rid of overloads, just to keep it simple. So we come back here, and that was, I do it every time, network.named. Now we look at the parameters, you can see All right, we come back to our int. If we come back to the Java side, we look at the parameters. This says string name and lowercase int age. So what happens in the compiler is if it's a non-nullable type, the Kotlin compiler cheats by using the bytecode primitive. So you get like one of the reasons for the primitive wrapper distinction is performance, especially in the early JVM levels. So Kotlin takes advantage of that, and if it's a non-nullable type, it uses the primitive value, because it knows it's never going to get a null assigned to that, right? So that actually shows up in your API. So from the Java side of the world, you'll get this lowercase int. But if I were to come back in here and say, actually, I want this to be potentially nullable, and we come back here, hopefully you can see this, maybe not from the back. This actually changed to an integer instead of an int. So the bytecode changed. So while it's a relatively minor change from the Kotlin side of the world, it can actually cause significant changes on the Java side of the world. Because if it's an integer, you suddenly have to start worrying about null on the Java side of the world. And this actually, depending on which direction you go, it could be a breaking change, especially if you're moving from a nullable type to non-null. Because if everyone's passing around integers and now suddenly you switch to an int, it can get weird. Auto-boxing kind of glosses over some of that from the Java side of the world, but you run the risk of introducing null pointers if you rely too heavily on auto-boxing. So just know the nullable type will change the types on the Java side of the world, and the Kotlin side doesn't entirely care so much. So that's important to know. Another place where you can't quite smooth over the fact that it's Kotlin is, what's that? String, that's actually a very good question. The question is, what about string, and how does it look different? It actually looks the same, because a Kotlin.string or Kotlin.string question mark just compiles down to Java-lang string, ultimately, which is already a reference type on the Java side, right? So that actually doesn't cause a change in signature for that particular type. The only place you'll really see this show up is if you're dealing with what essentially is a Java primitive from the Kotlin side. So int, float, double, byte, short, char, and Boolean. Almost certainly it uses annotations. Kotlin makes heavy use of annotations for a lot of its magic, which is sort of fun to look at. All right, so let's take a look. Here's our named function. There we go, it jumped. So this is what the bytecode looks like with the nullable type. I don't even see any annotations. So if we take off the nullable type, we can see, since we're looking at the bytecode, this is how it actually works with the default types. You get a synthetic method generated in the bytecode that applies the defaults and then delegates to the other function. And because it's synthetic, you can't actually call this directly from Java. I tried the other night. It's like, I can see the bytecode, I'm going to call it. But it's synthetic, which means the compiler generated it, and it's not visible from source code. So you can't call that method directly. But getting back to the original question, what does it do to the signature? So for string, it doesn't change anything. And then, and for this, I would expect it would go from Java-lang integer. Yeah. Well, there is this annotation. This is where it gets into I can't read bytecode that well either. I think what this not null annotation applies to is the final parameter in the named signature. So, okay, yeah, see, this I is the bytecode type for int. So the primitive is represented bytecode by this capital letter I, which is odd. And then if we go back to this, you can see it bounces back to integer. So it definitely changes the bytecode, of course, and then how it looks from Java changes as well. Does that make sense? It's a little exotic, but it's sort of fun to play with. Okay, so lambdas, very nice to work with in Kotlin. Not quite as nice from the Java side as we'll see. So in this case, we have a function called Lambda, helpfully, and it takes a function that takes no parameters and returns unit. So basically, if we wanted to call it, we would just say Lambda, and then we can pass in our Lambda, and it can do whatever it is that we want to do, right? So it looks pretty natural in Kotlin. You pass in a Lambda, it just works, right? What it looks like from the Java side of the world is a little bit not quite so nice. So we still have the Lambda function, as you can see, but why is it trying to do that? It's trying to autocomplete that for me, and it's not. All right, there's our Lambda. So now we're calling the function Lambda, but if you look at the signature, it starts to get a little ugly. So there's this type called function 0 in the Kotlin standard library. And what it sounds like is it's a function that takes 0 parameters, and you can see, maybe not so much, it's generified a little bit on the unit type. So in Kotlin, like void, instead of void, we have unit. So this Lambda doesn't return anything. So in Kotlin, it returns unit, and the generic type is also unit. So from the Java side, this looks a little weird. So if we were to call it, then it would look something like this. Now, if you remember in Kotlin, we can actually do this. It's fine. There's no body, there's no return, there's nothing. It's just a Lambda that returns unit. We're done. But because of the way that the signature is declared in the bytecode from the Java side of the world, we still have to return something, right? Because if you remember the function type on the parameter, it's a function. Let's just take a look. If we take a look at function 0. All right. So it's not as helpful as you might hope, but it's a function. It takes a type R and it returns a function R, right? So we have to, and here you see the invoke, and there's a return type of R. So from the Kotlin side, it's unit, the compiler is done. From the Java side of the world, it declares that it returns a type, and it doesn't know what unit is, right? Even though it's the Kotlin version of unit, as far as Java is concerned, it's a type. So you have to return something, and so you have to start doing like ugly things like that. Well, why does it? Oh, what's that? Yeah, that's what it's complaining about. But you could do this other things too. You could do something here, there. Now it's not complaining. It didn't like the single line thing, which was totally ruining my point. Anyways, so you pass in your Lambda, and you can do like all your normal Lambda things, but because of Java's type system, you have to explicitly return something, and you have to return null. And that's sort of ugly, but there's no way to fix that I've found. There's no annotation that can convince the Java compiler to not expect a return type, because that's just how the signature works. So this is one of the places where you're not going to be able to get away with some sort of the Kotlinness of your library coming out. If you don't do a lot of Lambdas as parameters, not a big concern, but sometimes it's going to come out. So, all right, what time is it? 2:38. All right, a few more minutes. Okay, so who's familiar with data classes in Kotlin? A few hands, okay. So what the data class looks like is this. Oh, that's not it. What? Oh, I'm in the wrong. I was in the test directory. So we have data classes. So this is what a data class looks like in Kotlin. The nice thing about a data class is it looks just like a regular class, all right? So if I were to declare a class in Kotlin, that's kind of all we need to do. The nice thing about a data class is it gives you a few things from the Kotlin side of the world. You get a toString automatically, and you get hash code and equals for free. You also get like if anyone's familiar with C++, you get a copy constructor. It's not really a constructor, but you get a copy for free, and you get, if you're familiar with destructuring in Kotlin, you actually get the component 1, component 2, component 3 methods for free in a data class, which we'll see. So what a data class looks like from Java, and what do we call it? We call it something creative, user. Okay, so we can do this. We'll say new user, and we'll give it a variable. So we'll declare it. And it expects parameters, of course, and the parameters of needs an ID, it needs a name. Go away. Am I running out of time? 10 minutes, okay. And it needs a password. So it looks like a regular class from the Java side of the world, and that's perfectly fine. Where it might start to get weird for people who like to dig into the API is you start getting some weird methods here. Is that readable from the back? I hope it is. It's bigger than I expected, which makes me happy. Let me do this. There. Now, hopefully everyone can see everyone's heads. So you can see there's component 1, component 2, component 3. The compiler generates those because it's a data class. And then you get, here's a copy method. For those of you who aren't familiar with data classes, this is actually kind of handy if you have a data class and you want to you want a new version of it, but you only want to change one parameter. These are actually defaulted methods on it. So from the Kotlin side, you could say user.copy, and maybe you want to update the password. You could say user.copy password equal and what the new password is. So you get everything else is exactly the same, you're just redefining what the password happens to be, which is sort of helpful if you want to mutate your data class. And then of course your get name, get ID name, password, you see toString, and there's other bits on there. Okay. These are actually all the helpful hints that IDEA gives you. So anyways. So that's what a data class looks like from the Java side. It's nothing terribly harmful necessarily, but people might wonder, what is this component 1, component 2 bits? And if you're not familiar with data classes, it can be weird to see, but anyways, data classes. One more thing, and then we'll hopefully have some more questions. Who's familiar with inline classes? 4, we'll go with 3.5 people. So inline classes are great. So let's say we have a function, update, and it takes a value, that's a double, and then the increase, and it's also a double. Now the problem with calling this function is you have these two types, and they're both doubles. It's possible to call them in the wrong order, and then you'll get weird behavior because you're passing in their syntactically valid types, they're just in the wrong order, right? We've all written code like that, right? You get them in the wrong order. Switching JUnit from test in G, I do it all the time. So what an inline class does is it lets you do this. We can now, instead of passing in this second double, we can pass in a rate, right? So now we're passing in a class instead of that. And now the compiler will tell us, you got this backwards, fix it, whatever, because it won't compile. Now, if you're concerned about performance, the one question you'll have is, but wait a second, now we're creating all these objects, and objects can be expensive, right? But what the compiler is actually doing is it will inline these classes to the function call site, right? So you can do, if we do this, return value times, you can say increase dot value, and it's going to want to return the double. So you treat it just like a class, okay? But what happens at runtime is that this rate type is removed, and all that actually goes into the bytecode is this value reference. So in the bytecode, you're only really dealing with this double type. But from your Kotlin source, it looks like you're dealing with an actual type. So you can wrap all your types, all your primitive types, in semantically meaningful things. So for example, if this was a price instead, which of course we haven't defined. So now your function parameters can have semantically meaningful types. So when you're looking at the API, you can figure oh, that's what these things are. You can have that, but you're not paying the cost of having, thousands and thousands of objects created for what is essentially basic math. Yes?
So if you decompile back, the result box, we see double.
Kind of. And this is the sad thing that I discovered this week. If you use these inline classes in your function signature, these methods are not usable from Java. And here's why. Let's make this compile. All right, we have 5 minutes. I'm going to rush through this because if there's any questions, we can dig into this, but if there's questions, I want to make sure we get to them. So here's what this looks like. All right? If we just say, let's do this, because I want this to compile. And it takes a double. All right, so here's the bytecode that we'd expect, and you see this update function just like you'd expect, right? And you see this dd, so d again is the double bytecode type for the primitive double, right? So that's what you would see from the Java side if you tried to call this. You'd see a method, it takes 2 doubles, you're done. But if you change this to a rate, now you'll see our update function is now gone, right? Instead, we get this update dash fz2jray. And if we try to call that from the Java side, it was in inline classes dot, we get this. IDEA finds it, but this dash is not a legal source identifier in the function name. So this function is literally uncallable from the Java side of the world. And I know what you're thinking. We saw the @Jvm Name Annotation, right? So we can just go in. If you'll let me click back. We'll just go in and, we'll fix it. Jvm Name, and we'll force it back to update. It's all red underline. The Kotlin, this is not an applicable application of this annotation because it does this inline class parameter. And I understand why this happens, but for me it was like terribly frustrating. I was hoping for like some synthetic methods over on the bytecode that would delegate and this and that, but it's not how it works. The Kotlin compiler does more trickery to make it happen, and the Java compiler doesn't have that magic. So inline classes are super useful and handy from the Kotlin side of the world, but they are fundamentally incompatible with Java. So if you do this from your Kotlin API, you're basically making that function unusable for Java, at least at the moment. Now, inline classes are an experimental feature in 1.3, so this may clean up by the time they take the experimental tag off, but at the moment, this is not doable. So, and that is, I think we did it. We have 3 minutes. Yay! Okay, that's all my list. So we made it through. I'm happy. Sometimes I don't always make it through because we have questions, so that's fine. Are there any questions? Do you want to go back to anything or dig into whatever? We can tackle whatever you'd like to hear. Yes?
Yeah, to ask some questions about data classes. So the question is how we can tune them. Like, how can we get annotations, for example, for fields if it's declared in so concise way, like one line? How can we tune them? Like,
how can you do what to them?
How can we tune data classes when it's declared as one line? For example, I want to add an annotation to some specific field or delete some, field from equals or hash code or something.
Well, you get them for free in a data class. Let me take that off, otherwise it'll never compile. Why are you? Oh, that's why. Showcase test. All right, everything should compile again. So just because you get them for free doesn't mean you can't do your own thing. So you could come in here, declare a body, and now we're going to overload the equals method. So you could come in and declare your own if all you cared about is, let's say, other is user. Then you could say return ID equals other.id. Why does it say? Oh, SmartCast it. So you could do that if all you cared about, do the IDs match. You can define whatever equals you want if you have some sort of specialized function that you'd like to provide instead, or you can just use the defaults.
And what about some simple stuff, like, for example, when we use it with Jackson, we want to add some annotations to the fields. So can we do it in a simple way in order not to define some, additional functions, additional fields, and so on? It's just, I'm not sure whether it's really used in this way, like without any annotations, without anything else, just clean data classes.
You could do it this way. I don't have Jackson in this library or in this project, so it's not going to resolve. But you could define the annotation, I believe, like this, directly on the property inside your constructor parameter. Now, for a data class, they have to be inside this constructor list. You can't have it otherwise. Because the whole point of a data class is here's all your data elements, and once you create it, you're done. 1 minute. Any other question? Yes?
Is it really a production case when we can use Java and together with Kotlin?
Where you can use Java what now?
With Kotlin.
Yes. There are.
Is it used in production, really?
Yes, absolutely production ready. I live in New York. I know people that are using Kotlin in like the financial industry, both on the Android side, of course, but then a lot of the backend services are implemented, like their microservices and such are implemented in Kotlin. And it's absolutely production ready, and the performance is roughly on par with Java, because it compiles down to bytecode with like you add a jar to your project, and it's just there. But yeah, absolutely you can use it in production. Any other question? Oops, wrong button. I want to put up. For those of you who are new to Kotlin or still learning, here's some resources. The website is great. There's also a Slack if anyone's into that sort of thing. The Slack channel has something like 20,000 users on it, and a lot of the JetBrains people. So if Slack is your thing, that's there. If any IRC users, there's a Kotlin channel. I actually run the Kotlin channel on Freenode, so that's there. You can try, if you want to just try out stuff, if you can see that, there's try.kotlinlang.org, which is like an online compiler. You can write code in the browser and run it and try it without having to download anything. And of course, find a local meetup. Hopefully there's a Kotlin meetup somewhere. If not, then you start one. Anyways, I think that's all my time. They're staring at me. So thank you so much for coming. If you have any other questions, feel free to find me afterwards, and I'll be happy to talk about it. So thanks.